Going to start chapter 6. Chapter 6 deals with triangles that are not right triangles. So far we've been looking at solving triangles and applying triangles to real-world applications, different things that always involved a right triangle, and therefore SOHCAHTOA always applied, and also the Pythagorean theorem always applied. So now we're going to look at some triangles that are not right triangles, because certainly all the triangles in the world are not right triangles. That would be kind of fun. All right, so we need to come up with a new rule. The new rule that the notes are not in your yellow packet. Sorry, guys. So you can just take out a plain piece of paper. And your calculator. You're going to need a plain piece of paper and your calculator. Everybody. If you don't have a calculator, go grab one from the top left drawer of my desk.
I got a new one now. And now it doesn't have a spot. So it's a big spot.
Lead?
Oh.
I used to have lead.
Oh. I think it was some term dorky. I'm not sure that's how to say it. So now my mother has this. You want to get a nice girl. So you get 2 cars, but you have to settle for right. You're having your batteries are low.
I just remember
I know. I would want it.
She signed it. All right, let's begin. We're all ready now. So today's lesson is called the law of sines, and this is one method we're going to use to help us solve triangles. And I want to show you where the law of sines comes from, so I didn't just like pull it out of the hat. So you have here a triangle ABC. None of the angles are right angles. They're all just random angles. They could be acute, they could be obtuse. They're just random angles. If we drop a perpendicular in that triangle, we drop a perpendicular here, then we've essentially created a right triangle, and now we can apply a right triangle trig to this triangle to develop a new rule called the law of sines. So I'm going to call this perpendicular that we dropped, I'm going to call that the height, because that's what it is. It's the height of the triangle. And then I'm going to look at just this triangle right here. I'm just going to look at this piece right here, which has a right angle. And relative to angle A, the sine of A is equal to the opposite side, H, divided by the hypotenuse, B. And then I'm going to look at this triangle over here. I'm going to isolate this triangle. And now, relative to angle B, the sine of B is equal to the opposite side over the hypotenuse, or H over A. All right, so now we have two equations involving sines and angles and the sides of the triangle, and they both have an H in them. So in this first equation here, I'm going to solve for H by just multiplying both sides of the equation by B. And then the B's drop out, and I just get H equals sine A. Sorry, the B doesn't drop out over here. I don't know what he's doing. B's drop out just on the right. There we go. And we get sine A times B. Now, do a similar thing with the other equation. This time, I'm going to multiply both sides by A to isolate H. And then I have H equals A sine B. All right, so now if H equals sine A times B and H equals A times sine B, then by the transitive property we know that sine A Now, ultimately, I'm trying to show you how we derive this law of sines. And it looks like with the law of sines, we have sine A over side A equals sine of angle B over side B. So I want to get the A's and B's in the denominator. So I'm just going to divide both sides of the equation by AB. Divide out the B's, divide out the A's, and we have sine A divided by A equals sine B divided by B. So there's our law of sine. So that's how, in a triangle that isn't a right triangle, we can still relate the sine of the angles to the opposite sides. Now, I could also, I could drop a different perpendicular and this time involve C and the sine of C, and then I would get the whole proportion. But it's, repetitive, it's the same idea. So as you work with this law of sines, depending on the sides or angles of the equation you're interested in, you're either going to use like this part of the equation, or maybe you'll just use this much of the equation, or maybe you'll involve sine A and sine C and relate those two. So you just set up the proportion that's convenient for whatever it is you're trying to solve. And we'll take a look at that with some problems. The other thing we can do is, with proportions, you can always cross multiply and then divide to solve, or we can take the whole proportion and basically flip it. So I could also write this as A over sine A equals B over sine B, and that would be a true equation as well. So just, using your rules for proportions. So
how would you do the sine of C?
how would what?
What would it be for the sine of C?
So it's going to be the same thing. Like I'm going to use, maybe I would already be given this angle B and side B and side C. If I knew all those three things, I would just set up this proportion and then solve for the sine of C.
I meant like the ratio, like, you know how sine of A equals H over D?
Yeah.
How can you get sine of C?
Okay, so here we dropped a perpendicular from this angle. So now we would have to drop a different perpendicular so that we would have, and I'm not sure, let's see, trying to look at how you would draw that. Would probably we would have to, what we'd have to do is probably extend this side so that we could drop the perpendicular right here, something like that. And then we would have two triangles again. All right, so let's take a look at an application of the law of sines. So here's an application. And the way the applications are organized by your textbook are by cases, depending on what the given information is. So in this problem, this may take you back to geometry when you did angle, side. In this case, an angle is given, and also a side is given. And we're going to solve for the remaining angle and the other two sides. Okay, so I'm just going to label the diagram. First of all, our given information is that angle A is equal to 122.7 degrees. We're also given that angle B is equal to 34.4 degrees. And we're given that side B is 18.3 centimeters. Now, when you look at the way these triangles are drawn, I drew this one sort of to scale. I mean, at least the 122.7 looks like an obtuse triangle. You may see problems in your textbook or on the test or something where the triangles aren't necessarily drawn to scale at all, but they're just used kind of as a schematic to help you have something to label and visualize which sides are opposite the angles. Okay, so this one's kind of, it looks roughly like the correct angles and measures. All right, so we want to apply the law of sines, and you want to have a proportion where three parts of the proportion are given and another part is unknown. And that's what you're going to solve for. But before we even start down that road, let's think about finding this third angle in the easiest manner. Okay? Easiest way to find that third angle is to do what? Subtract from 180. Okay. So let's start there. Okay, so do you all get 22.9 degrees? All right, so we're going to get 22.9 degrees for this. So now, the only things that I don't know are side C and side A. So I want to ultimately solve for those. So I'm going to involve in my law of sines. I'm going to definitely want to have side A and angle A. And then the other two, characteristics that are opposite each other would be side B and angle B. So this is given, this is given, this is given. That allows me to solve for A. So I would set this up as A divided by sine A equals side B divided by the sine of angle B. And I set it up with the A's and B's on top because I want to solve ultimately for A, and that's the easiest way to solve that in that proportion. So if I want to solve for A in this proportion, I can just multiply both sides of the equation by sine A. There's sine A here, sine A here. Now the sine A's divide out. I've solved for side A, and I'll just plug in the values. So the value of side B is 18.3 centimeters. I'm going to multiply that by the sine of 122.7 degrees and divide by the sine of B, which is 34.4 degrees. All right, so let's think for just a moment about the unit analysis here. I'm solving for side A. That's a length, that's a distance. My units so far are centimeters. The sine, when we evaluate the sine, that's just a ratio. There's no units on that. And we evaluate here, no units on this. So the only units on the right-hand side of the equation are centimeters. So that means our answer will be centimeters.
I wrote my keep writing
Oh, okay. So when you label the triangle, it's really helpful to label angle A opposite side A, angle B opposite side B, and angle C directly opposite side C. And I, just for convention, I'm using capital letters for the angles and lowercase letters for the sides. Okay, so take a minute, put that into your calculators. Anyone have a distance for a length for A? 27.26. Anyone else confirm that? Okay. All right, so that's going to be centimeters. And it looks as though all of our given information was rounded to one decimal place, so I'm just going to round to one decimal place, and I'll just say that A is approximately 27.3. Okay, so now to solve for side C, I'm going to do the same thing again, and I'm going to use the given information in my proportion. I'm going to compare angle C and side C to angle B and side B, because that was given, and I know that those numbers are like definite numbers. I didn't round any of those off. However, when we evaluated side A, we rounded off a decimal. So we're going to get a more exact, precise answer if we start with the given information. So I'm going to write side C over the sine of C, and that equals side B over the sine of B. And then again, I want to solve for the sine of, or I want to solve for side C. So I'm going to multiply both sides of the equation by sine C. That stuff all divides out. And now I'll just fill in the information. So B we know is 18.3, and again, centimeters. Did I hear somebody talking about wanting to cross multiply and divide? Can you do that? Of course you can. You can solve it algebraically however you like. That's no problem. Okay, multiplying by the sine of 22.9. And then dividing by the sine of 34.4. All right, who has a final answer for C? 12.6, okay. So that's here. Okay, so again, as I said to you, don't worry so much about it being a scale drawing, but think of it as a schematic. But what you want to take a look at is notice that the longest side, which is 27 here, is opposite the longest angle. And the smallest angle is opposite the shortest side. And certainly it's not drawn to scale because this looks... What's that? Oh, yeah, I put a degree symbol there. Okay. So, thanks, Calvin. Okay. So did you guys follow what we did there? Just send for proportion, find 3 things that you know, the 1 thing that you don't know, and those are all going to be in your proportion. You're going to choose the right version. Okay, so let's take a look at one more example quickly, and then I'll let you get started. You do have homework. Sorry. Okay, so here's another case. The first case we had was angle, angle, side. We were given 2 angles and then a side. This time it's the case of angle, side, angle. You're given 2 angles and included side. The process is going to be the same for solving either one of these. So this time when we're given angle A, that is 41 degrees. We're given angle B as 3 degrees, and side C is 21 miles. Okay, why don't you guys take the next 3 or 4 minutes and solve for the remaining angle, side A, and side B. Take a few minutes to solve that. What did you guys get for angle C? What do we have for that? Okay, 136 degrees. All right. Does anyone have side A yet?
Yeah, 19.83.
What is it?
19.83.
Okay. So
Actually, no.
19.83. And who has side B? What'd you get, Michael? 1.6? Anyone else confirm that? 1.58, so 1.6, okay. I'll put 1.58, that seems good. Okay, so now, just quick eyeball that. Do we have the shortest side opposite the smallest angle? Looks like you do. 1.58 is certainly the shortest side. And then we have the longest side, 21, opposite the largest angle, 136 degrees. Okay. Did anyone have trouble setting that up? All right. Then let's take a look at what your homework is for tonight.